First of all, I would like to say good afternoon to server Health
Good
Talait,
afternoon.
7 Newton, 7 Edison, and group mates. By the way, my name is Fatma Fach Bashir, and it's now my turn to explain to all of you the topic that has been assigned to me, which is all about the special product square of a binomial. Before we get into it, let's talk about first the word special product and square of a binomial. So what is special product, or why do we call it special product? Why do we call it special product? It is called special product because there is a specific pattern that squaring a binomial creates. You can multiply the two binomials, for example, a plus b times a plus b using the FOIL method, or you can use the pattern. So we have here when you FOIL, a plus b times a plus b is equal to a times a plus a times b plus a times b plus b times b equals a squared plus ab plus ab plus b squared. Now, what is squaring a binomial? Squaring a binomial or multiply a binomial times itself. So we have here the same example, but this time we're going to use the pattern. So we have the pattern and the quantity of a plus b squared is equal to a squared plus 2ab plus b squared. While on the other example, it's just the same but different operation. We're going to use this time the subtraction. So the quantity of a minus b squared is equal to a squared minus 2ab plus b squared. In each pattern, the middle term is twice the multiplication of the term used to create the binomial expression, which is this part. So it's obviously notice how the sign of the middle term is positive in the quantity of a plus b squared and negative in the quantity of a minus b squared. Now, let me give you some example and how do we get it. But before that, let me clarify something. So some people, they think that this is a pattern. So we have here the quantity of a plus b squared is equal to a squared plus b squared, and the quantity of a minus b squared is equal to a squared minus b squared. But this is wrong. Be careful. While this may look like a good idea, it is not true and it will definitely give you the wrong answer. So moving on to the examples, we have here a geometric display. Take a look at the picture at the right side showing a geometric display of the square of binomial a plus b. The picture shows a large square whose sides have a length of a plus b and also a width of a plus b. Inside the square are two smaller squares and two congruent rectangles. Let's talk about first this part. You can see the needed middle term when multiplying a plus b times a plus b. The picture also shows how the middle term is represented by twice the product of the two terms from the binomial. So 2 times ab is equal to 2ab. So just like what I said a while ago, the middle term is twice the multiplication of the term used to create the binomial expression. So a times b is equal to ab, b times a is equal to ab, alphabetical order. Now let's talk about this part. The area of the larger outer square equals to sum of its interior components. So we have a times a is equal to a squared, b times b is equal to b squared. So a plus b times a plus b is equal to a squared plus 2ab plus b squared. Therefore, the quantity of a plus b squared is equal to a squared plus 2ab plus b squared. And that is now the pattern.
Good day everyone, I'm Jasmine Bayaling. I am tasked to report special product square of a binomial. What is the square of a binomial? The square of a binomial is the sum of the square of the first terms twice the product of the two terms and the square of the last term. I have prepared three examples, but let's look at example 1 first. We have here the square of 3x plus 2. You can use the full method in getting the product, but you can also use a pattern, which is what I'm going to show you today. So you're going to square x. To get the middle term is twice the product of x and y plus the square of the second term y. So we are going to square x, so that is 3x squared plus twice the product of x and y, that is 3x and our y is 2 plus the second term y, so that is 2. So 3x times 3x is equals to 9x squared. 2 times 3x is equals to 6x. 6x times 2 is equals to 12x. 2 times 2 is equals to 4. So the product of the square of 3x plus 2 is 9x squared plus 12x plus 4. In example 2, we have here the square of 2x minus 5. So the operation here is minus. So the pattern that we're going to use is x squared minus 2xy plus y squared. So we are going to square x, so that is 2x squared. Minus twice the product of x and y. Our x is 2x and our y is 5. Plus the square of the second term, 5. So 2x times 2x is equals to 4x squared. Negative 2 times 2x is equals to negative 4x. Negative 4x times 5 is equals to negative 20x. 5 times 5 is equals to 25. So the product of the square of 2x minus 5 is 4x squared minus 20x plus 25. In example T, we have here the square of 11 minus 3/4 xy. So we are going to square x, so that is 11 squared. Minus twice the product of x and y. Our x is 11 and our y is 3/4 xy. Plus the square of the second term, 3/4 xy. So 11 times 11 is equals to 121. It is understood that we have a denominator 1 here. So when we multiply a numerator, it should be multiplied by a numerator. And if we multiply a denominator, it should be multiplied by a denominator. So negative 2 times 11 is equals to negative 22. Negative 22 times 3 is equals to negative 66. 1 times 1 is equals to 1. And 1 times 4 is equals to 4. Copy x 1. Now you've noticed that a 66 over 4 can be reduced to a lowest term. It has a GCF of 2. So negative 66 divided by 2 is equals to negative 33. 4 divided by 2 is equals to 2. And copy xy. So the answer is negative 33 over 2xy plus 3 times 3 is equals to 9 and 4 times 4 is equals to 16. You can use the power to a power law when you multiply the exponent. So 1 times 2 is equals to 2. And 1 times 2 is equals to 2. So the product of the square of 11 minus 3/4 xy is 121 minus 33 over 2 xy plus 916 x squared y squared. Thank you for watching.